Hi, I'm Francis Campo and this is Just for Funk. Welcome to episode number 34 of Just for Funk. Today it's kind of a special day because I'm going to do the first episode of a slightly new series. Think about it as a mini series that is part of Just for Funk, which is going to be Just for Funk on machine learning. So what we're going to do is we're going to mix my two favorite things, machine learning and Go, and basically do them together. So we're going to do machine learning with Go. This first episode is going to be quite basic, and we're going to concentrate on a very, very necessary skill when you're doing machine learning and basically any kind of data science, which is how to plot data. I did an episode a long time ago on how to plot data by basically writing everything from scratch. This time we're going to do it a little bit differently. And we're actually going to use gonum plot, which is a really, really good library that is similar to pyplot if you ever used it for Python. Does that sound fun? Let's get started. Okay, so the goal of today's episode is to plot a bunch of points on a plot, on a graphic, right? So basically, I have this data.txt file that contains a bunch of different pairs of floats, and I want to somehow represent them on an axis. Sounds pretty simple, but how do you do it? I've done it many times with Python and pyplot, but I've never done it with Go. So I thought they'd be a very good place to get started and see how easy or hard it is to write basic data manipulation algorithms with Go. The first thing you're going to do is, as always, create a main.go, and we're going to need to somehow read all of this content. So I'm going to say read data, and we're gonna pass data.text, and that's going to give us x and y's and an error because maybe it fails, and the error is not nil. We're going to do log fatal f could not read data.text, and this is the reason why. Otherwise, we'll do something with x, y, s. We don't know it still yet, so let's leave it there for now. Okay, so read data, given a path, it's going to return something that we need to decide. Let's say we're going to return actually, let's say that we have a type xy struct that contains x and y, which are float 64s. So now what we're going to do is we're going to return a bunch of xy's and an error. Cool. So what's next? We're going to, there's a bunch of different ways of doing this, but I think that since files might be quite big, we're going to try to do it so we don't need to load all of the file in memory. So we're going to be using, rather than io-util read file, we're actually going to open the file and read using a scanner, read line by line. So how do we do that? We're going to do os open of path, and that will get us a file and error. If the error is not nil, we will return nil and an error saying could not open. Actually, since we're already giving enough information, I feel like that should be enough. That's enough context. I see very often people adding context to every single error all of the time. And you need to take into account that the goal of adding context to the error is to make it so when something fails, it makes sense to you and the user to understand what happened. Here we'd say could not read data.txt and probably something like it does not exist. That's enough for me. Okay, so let's make sure we close the file at the end. And now what we're going to do is we're going to use the pathio.scanner, which normally it's used for reading from standard input, but also works very well for this case. So we're going to do a new scanner, and a new scanner receives a reader. A file is a reader, so that's perfect. And so for scan return, so if s.error is not nil, return could not read and this the could not scan. Let's say could not scan, and there is the reason, and nil here. This is basically the normal pattern when you're using a scanner. You create it, then you do for scan many things. Inside you do s.text or s.bytes, depending on what you want to work with. And then at the end, you need to check for that error. That is quite important because if you're reading from this file and at some point the read operation fails, you will not see it by getting s.text. That will not be a panic. But what will happen is that s.scan will return false, so the iteration will finish, and s.error will return the corresponding error saying something happened to the file. Okay, so knowing that now, let's declare xy. It's a slice of xy, and what we're going to do is we're going to need to let's print it for now. Just print the text to make sure, and this is going to return xys and nil. So for now, this should just print all of the data that we have. Cool. So that looks like it works. That's pretty good. So now what we want to do is we want to split that thing. Actually, we could split that thing and then use the scanner. So that would be basically split.string on the comma, and then read every single one of them, and then check for the error, etc. And that's a way of doing it, but I think that there's a better way, which is using the same way there's sprintf, there's scanf. So you can give the string, and you can say we have a float, then another float. And we're going to be reading that into x and y. Those need to be pointers. X, y are float 64s. And that will maybe return an error. If the error is not nil, we could return an error, but when you're doing data science or anything with with really big files, it is actually good to be quite robust when something is not good enough. So rather than just returning an error and stopping everything, what we can do is simply log discarding bad data point, and let's print it as a quoted string and give the error too. So that would be s.text and the error. Whoops. Okay, so let's do it like this. Should be able to read it better. And if all of this works well, then we're going to do xys equals append xys of an xy of x and y. Cool. And then we return xys. So now rather than printing it, this should still work, but don't do anything. It will not print anything. Now we're going to do is for xy range xys, println x, xy.x, xy.y. So that should print all of the numbers, but now separated like that. Cool. So this looks pretty good. Now we're able to read all of the data. That is the first step. Basically, every single kind of machine learning is to be able to read things because we're going to be training a model with a lot of data. So the first step is to load that data, and we got there. Cool. Okay, now the next step is the interesting part, which is we're going to plot this. So how do we plot it? Well, let's see the documentation. So if we go to gonum.org/v1/plot, actually, if you go to gonum.org, I think that you should see the documentation for gonum.org. This is a great library. I really like it. I gave a talk. It's called Machine Learning for Gophers. I think that was the name, .go. I will have a link to that video. Brad Fitzpatrick was making fun of me because I was not able to make it right. So I'm going to think about where is the link. Since you see me like this, I'm going to say that the link is going to be here. And if it's wrong, I will probably just edit the video and just flip it out. It will look really weird, but funny. Anyway, you can watch the video where I talk about how Gonum has amazing libraries. It's actually a set of libraries, not just one library, but it is not perfect for me. I think that the matrix, the way you manage matrices is not very comfortable. It's the API is kind of weird for me, but still the way you plot them though is super good. So we're gonna go to GitHub and plot. There you go. So that is the one we want to use. And then, oh, I know Sebastian Binet. Hi, Sebastian, if you're watching the video. He's super cool guy. He allowed me to get to see the CERN, the Nuclear Research Center in Switzerland. It's amazing. Looking forward to be back at some point. Okay, so let's see the documentation for this. It's gonna be here. Cool. So now we have the documentation. And we have a type, it's the type plot, and you can do type new plot. And that is basically the first point. You want to create a plot, you need to call plotter, actually plot.new. So let's do that. I'm going to simply drop all of this print in here, and we're going to do plot.new. And I think that I messed Go imports in my computer, so I need to fix it, but I'll fix that later. Instead, there you go. So that's plot.new, and that returns a plot and an error. If the error is not nil, we're going to log fatal f could not create plot, and that is the reason why. Otherwise, we're going to do a lot of things to the plot. But at the end, the important part is we're going to call this writer2, where we give the size. So let's say 512 by 512 pixels. We want to generate a PNG. That is a writer2 and an error. Again, if the error, I did something weird there. So if the error is not nil, we're going to say could not create writer, and this is why. Otherwise, we can do right. So p.writer2, sorry. And then we're going to do writer2, write2. We need to write somewhere. So that's going to be a file. So let's say we're going to create a file. OS create out.png. If the error is not nil, we're going to do log fatal f could not create out.png, and this is why. Otherwise, defer f.close, and we're going to write to f, and that will return something and an error. And if the error is not nil, then log fatal f could not write to out.png, and this is the reason why. Write to, okay, so there's no new errors there. So, okay. And XYS is not being used right now, and that's fine. I'm just going to write this just to avoid that error, that compilation error. Cool, so we create a plot, we write it, we create a writer for that plot of size 512 by 512 in PNG, and then we are going to write that into a newly created file called add.png. Technically, you should actually check f.close, because if closing the file fails, it would mean that the graph might not have been written correctly. I will not do it. Actually, I will do it. Why not? Okay, so if error is nil, log fatal f could not close out.png and return an error. Okay, this is pretty intense, but this is basically just to write an empty plot. Right now there's nothing in it, but it should be okay. So let's run it. Go run main.go. That works, which is pretty impressive, to be honest. And then we have something that is it completely empty? No. How do I zoom out? There you go. That's how you zoom out. Okay, so that is our graph so far. You can see it goes from -1 to 1 and both axes, and there's nothing inside. So that's pretty good, but it's not good enough. What I'm going to do is I'm going to refactor all of this code here, managing how to create a graph. I'm gonna move that into its own function, and then we will connect it so the data we read will be written into that plot. So let's do that. Plot data probably will pass XYS, and that may return an error. And if the error is not nil, actually we're gonna plot XYS to out.png. That's the information we need. And if that is not good, then we'll probably do log fatal f could not plot data, and that is the error. And let's write the function. So function plot data, given a path of strings. So a path is a string, and also XYS, which is a bunch of XYs, returns an error. And plot.new. Go imports having issues. I don't know what's going on with that. I'll figure out later. I don't want to do it while recording. Also, I think my laptop is about to catch fire. I think it doesn't really like when I'm recording at the same time that encoding. It sometimes has some issues. Apple, you should do better. Okay, so this still kind of works. We're going to modify all of these log fatal f to return an error. And in this case, we're going to return nil. So that's basically the same code as before. Also, I want to change the out.png everywhere. So this out.png should be path, and this one here should be a string, and that's going to be the path. Okay, that looks pretty decent. I'm decently happy with this now. I guess that I can move this so everything is a little bit more together. So we create the file first, we create the plot, then the writer too, and then we write it. We write it to the output to the file, and then we close the file and we check whether that worked or not. Okay, so now the piece that we're missing basically is how do we do the thing that we want to do, right? Right now, everything we've done is reading a bunch of data and then writing an empty plot. We want to add that data we read into the plot. Let's go back to the documentation and see how do you add things to a plot. Well, you call plot.add, and you pass a bunch of plotters. And a plotter is something that has an interface. And there's a link to this. And a plotter, let's see. So plotter, there's bar charts, there's box plot, there's contour, there's functions, there's grids, and heat maps, and histograms, and images. All of these things are things that you can plot. So let's try, okay, so scatter is the one that we want probably, because scatter is basically something where you give a point by giving the X and Y coordinates, which is what we have, right? So how do we do that? Well, a scatter, we can do it by doing scatter dot what? So new scatter, and then scatter data. Oh, so when you do new scatter, let's see that. We need to pass an XWire. XWire is an interface that allows us to do this thing, and one of the things that satisfies that is actually an XYS. So XYS is the concrete type. It's a slice of basically what we define as XY. The type XY in our code basically corresponds to this piece here. So a slice of those is what we call an XYS. And XYS has len and XY methods. Therefore, the XYS type satisfies the XWire interface. That is the one that we need to pass to new scatter. Harder to say than to write in code, really. So let's try to do that. When we create the code, let's say that we're going to, for now, let's create something that is probably not correct, but new scatter. No. Okay, so plotter, that is the plotter. So plotter.new scatter, and we're going to pass plotter xys, and the first point, let's say that we're going to have 1 point at 0, 0, 1 point at 0, 5, 0, 5, and 1 point at 1, 1. So these should basically create 3 points that are equidistant on the diagonal, right? Like 0, half, half, and 1, 1. So these returns a scatter and an error. If the error is not nil, we're going to return, what are we going to return? We're going to return the error, actually. So could not create scatter, and this is why. Otherwise, we're going to call p.add of that scatter. Okay, so let's print it again. So let's go run main.go and see the output. And look at that, we have those 4 dots, 3 dots, sorry. Okay, so I don't like these dots. Let's say I actually want to have those dots as crosses, because, you know, that's cooler. How would you do that? Well, the way you control that is once you have a plotter, in our case, that's scatter, you can modify things in it. So you can say s.shape dot s dot, let's see, s dot what, s dot glyph style dot shape equals I think it's drawer dot glyph, cross glyph. I think that's the name. Did that? Oh man, I was gonna say if that compiled, I'll be very, very surprised with myself. Is there a drawer? No. gonum.org v1 plot vg draw. So draw the cross glyph. No. Oh yeah, because that's a type, so you need to create a struct of it. Struct a value, concrete value of it. Okay, so let's see if that changed our graph. And it did change it. Okay, so what if now we want to make it, let's say we want to make it red. Well, it's gonna be a color, which is a color, which is an RGBA. So it's actually a color.rgba. Color is an interface in Go, and RGBA is one of the concrete types that satisfies that interface. So we're gonna say that the red is 255 and the alpha is 255. Otherwise it'd be transparent. It looked kind of weird. Okay, so let's run that. Boom, now it's red. Okay, I think this is kind of too big. So I'm going to make the graph a little bit smaller. I think it will help seeing the dots a little bit better. Perfect. Okay, so now we have our graph with 3 dots that are not what we want to do. The last step is to convert basically the data we have into something that the plot package will understand. So let's do that now, and then we'll be done. So let's ignore this part, and I'm going to try this. I really don't think this will work, but it could work. No, it will not work. Okay, because what we're trying to do is convert, so XYS is a slice of XYs, and this is a slice of structs. They're very similar, but they're not the same. What if we do X and Y? If the field names are exactly the same, maybe it is happier. Can I convert XYS type to no. It's sad, it doesn't work. Okay, so we're gonna need to do is PXYS, so our plotter XYS is going to be plotter.xys, XYS, and the length of XYS. And then for every XY in XYS, PXYS of I is going to be, so X is going to be XYF of X, and PXYS of I dot Y, XY dot Y. And then we can do PXYS here. range, sorry. Okay, so I'm going to move this back to lowercase actually. And also here, so that's going to be X and Y. Okay, so now if everything worked correctly, what we're doing is we're converting those X, Y, S, which are here, which really, you could do it so the read data returns that type already. But I feel like mixing what is to read data with what is to plot it is a little bit too much. So I'm going to keep it like this. So what this will allow us to do, actually, you know what? Let's do that. Let's say that this is going to be plotter.xys. So that way we don't need to do any of this. We can just pass the xys to this directly. And now what we need to do is read data should also return plot.xys, plotter.xys, sorry. And in order to do that, we're going to need to modify this to be plotter.xys. And it's going to be struct of x, y, float64, xy. So this is very similar, right? But now what we're doing is, since the plotter.xys is defining this weird way, where it's a slice of an anonymous type, we need to repeat the definition of that anonymous type in here. Otherwise, it will not work. There's other ways to do it, but I think this one is the clearest way. Okay, so with this, go run, and we got it. Cool. Okay, so in the next episode, what we'll do is go from this graph here to something that actually has also a line that approximates all of those points that we call linear regression. And we'll do that with a really cool library that I've been playing with lately, which is like TensorFlow for Go. You could do it with, actually, I might do it with TensorFlow for Go. There's TensorFlow bindings for Go. I may try that, but also I will try it with Gorgonia, which is a very cool library I heard about not that long ago, and I like to try it. But for now, just to show how that would be done, not the linear regression, but how to plot the line, let's just add it here. So what we're going to do is, so that was create scatter with all data points. And now we're going to create fake linear regression result. So we're going to do plotter.new. Let's see, new histogram, new label, new line. New line makes new line. Let's go with new line. New line gets xys. So, okay, so that will give us a line and an error. If the error is not nil, then we're going to return an error f could not create line. And that is the error. What are we going to pass here? We're going to pass a plotter.xys, and we're going to give 2 points. So let's say we're going to give, so a line is, the equation for a line is defined by 2 values. One is the how steep it is, so that is, let's call it x. And then the other one is where basically it starts at 0.0 for x, at what height for y it is. And normally that's called c. So those two are float64. And let's say that for our case, which is completely made up, x equals 1 and c equals 1 also. So we're going to do is we're going to give a point where we're going to say 0 corresponds to 0 times x plus c, so that is c, and then 1 corresponds to x plus c. Those are 2 points that basically let you know where that line should be crossing. And that does not compile because L is not used. We need to add it to the plot. And if we try to run it, and we get it. Okay, so it kind of worked, but you can see that actually goes from 0 to 1, so that is not good enough. We'll figure out how to do that better later on. But what I'm going to do is basically say, well, what is the last value we have? 20. Okay, so 20 and 20 times x plus c. That is the equation. And now, there you go. Now we get something that actually looks quite similar to what we want to do. Okay, and with that, that is the end of the episode. I hope you enjoyed it. It's a little bit different, but please let me know what you think about this. Is this something that interests you? How to do machine learning in Go? Also, the whole point about doing machine learning in Go is not necessarily that you will do machine learning in Go professionally, but you already know Go. And by doing machine learning in Go, you will actually understand the principles of machine learning. So that is my goal, to explain machine learning from scratch in a way that is as clear as possible, specifically for Gophers. So let me know if you like that. If we continue with that approach, the next step would be to try to implement that linear regression, which we did by hand, basically trying to figure out what was the best value by having a look at the graph. There's better ways of doing that. We will, in the next episode, probably do either TensorFlow or Gorgonia, or maybe both if we have the time. But that's only if you like this episode. So if you enjoyed this episode, please like it, subscribe, tell all of your friends. And as always, thanks so much for watching, and see you all in 2 weeks.